call it organic chemistry. So organic chemistry, that's what we are treating tonight. So mentioning the chemistry of compounds mainly. No, there is no compound that is organic. No organic compound that is ionic. Basically, we have chemical compounds being divided into types of bonds. So the basic two chemical compounds types are covalent compounds and electrovalent compound. So the electrovalent compound are also ionic compound. Please, we've started the class. So the electrovalent compound are also ionic compound. It's under the covalent compound we have the van der Waals force. It's under it we have the hydrogen bond. It's under it we have the dative bond. That is coordinate covalent bond. So it's under this covalent compound. While this ionic compound now involves transfer of electron, so covalent compound involves sharing of electrons. So therefore, the compounds involved in organic chemistry are formed. The compounds involved in organic chemistry are formed by sharing of electron between carbon and some other nonmetals. By sharing of electron between carbon and some other elements. Let's say hydrogen, which is the most common, that's the commonest element that combines with carbon to form an organic compound, hydrogen. We have another one too, oxygen. We have another one, we have the chlorine. So chlorine is more popular in it than chlorine. So all these elements now, we have nitrogen too. Yeah, in amino acids. We have nitrogen too. So these elements, they combine with carbon covalently to form what we call the organic compounds. So what I'm trying to draw out from this is that organic compounds are basically covalent compounds. They are formed by sharing of electrons. They are formed by sharing of electrons and not by transfer of electrons. Part of what we've been taught, as I'm saying again, that electronic combination involves electrovalent method and covalent method. The electrovalent method is also known as ionic method. Look at this. Sodium is a very popular metal. Chlorine is a very popular non-metal. When sodium and chlorine react, a metal reacts with a non-metal. They form an ionic compound. That's an electrovalent compound. So this compound is an inorganic compound. This compound is an inorganic compound. It's an ionic compound, it's an inorganic compound. But when carbon reacts with hydrogen to give CH4, you can see that this is the carbon element. This is the carbon atom. I'm sure it's a bit about. This is the carbon atom. We all know how to draw this. 1, 2. Carbon is 6, 3, 4. So this is the carbon atom here now. The carbon needs hydrogen to combine with it. So one hydrogen has just one proton. One hydrogen combines with it, another hydrogen comes in, another hydrogen comes in, another hydrogen comes in. The center is carbon, right? Hydrogen is here. Hydrogen is here. Hydrogen is here, and hydrogen is here. Basically, I have CH4. How is this compound formed? What I'm saying in essence is that this compound is formed. What I'm saying in essence is that this compound is formed by sharing of electrons between carbon and hydrogen, which is totally different from the compounds formed by transfer of electron between non-metals and metals. So basically, organic compounds involve non-metals. When we start having metals, it happens if they are in the ether mate. We call them esters. At the moment, don't let us drag ourselves too much. I say again that at the moment, let's just say that organic compound involve basically non-metals. So please, my explanation here, did we all get it? Is there anyone that doesn't understand my explanation? So please, emoji will be okay. Just be using the emoji to react, please. All right. Thank God I've seen a person. I want almost everyone to move with us this time. It's not mathematics. Is it just a person that understands? Kingsmith, this is thumb down. Okay, again. Let me come again. I said, basically, you can see I'm not fasting today. I really want everyone to understand. Okay, Mr. Ajayi. Okay. Please listen better. Please listen again. Origi is thinking about it. Don't worry. I believe I'll try to explain it better. What I'm saying in essence again is that organic compounds are compounds that are covalent. We said basically we have two types of compounds. In the two types of compounds now, we have the compounds that are formed covalently. What is covalent combination? Covalent combination means the reaction of elements by sharing of electrons. By sharing of electrons, sorry. By sharing of electrons, carbon is a non-metal, hydrogen is a non-metal. So carbon reacts with hydrogen by sharing electron with it. It can't give electron to hydrogen because it's a non-metal. Just take non-metal as a female. Take non-metal as a female. So carbon is a female, hydrogen is a female. As we all know, females collect from male, while male give to female. So now there is no male here. Let's call the males metals. There is no male here at all. So definitely we have female here. Female cannot give. They can't give themselves. They have to share what they have together. So carbon shares what it has with hydrogen that's also sharing what it has with carbon. So sharing now makes it to be like, sharing makes it to be that they are combining covalently. Let me use that to explain again. I said, take a metal in the periodic table. Take it as a male. This is sodium in the periodic table. It is a metal. Take it as a male. Take a non-metal in the periodic table, like chlorine, as a female. When male combines with female, I'm saying that male will donate for female. As we all know that men will always buy things for women. This is just Valentine's Day. So you guys can relate. So men will always give things to women. So male will always give to female. So the male will be the donor. He donates electron. What are they donating? Electron. While the females will be the acceptors. Acceptors are negative. Donors are positive. So males will be the donor, while the females will be the acceptor. So now I now have two females with me. The first female is carbon. The first female is carbon, and the second female is hydrogen. So now, the both of them, none of them is a male. It's not possible for both of them to be donor. So since there is no donor, there can be acceptor. So the both of them are going to share what they have. This one will bring what it has forward. This one too will bring what it has forward. They are now going to share it together. So sharing it exactly, sharing that thing exactly means covalent combination. It means they are combining covalently because they are sharing their electrons. It means they are combining covalently. In sodium and chlorine now, they are not sharing their own. Sodium is definitely giving chlorine. So they are combining ionically or electrovalently. So covalent combination gives rise to covalent compounds. So these covalent compounds could be combined by van der Waals forces, like iodine gas is formed by van der Waals forces. Hydrogen bond, like water, hydrogen fluoride, they have van der Waals forces. Hydrogen chloride too. Dative bond, like ammonium chloride, they have dative bond. Dative bond is also known as coordinate covalent bond. So what I'm saying is that organic compounds are exactly covalent compounds that are formed by sharing of electron between carbon and hydrogen or oxygen or fluorine or nitrogen. They are formed by sharing of electron. There is never transfer of electron. This is a very important aspect. There is never transfer of electron between carbon and hydrogen or any of them. It is rather sharing of electrons. Sharing of electron between carbon, hydrogen, or carbon, oxygen, or carbon chlorine, or carbon nitrogen, or even almost all of them together. Sharing electron. So please, did we get it this way now? So all organic compounds are okay. Okay. All organic compounds are covalent in nature. They are covalent in nature, a very typical characteristic. Intimate, let's hear you.
Please, there was a statement you made before. You said that electrovalent compounds are formed by transfer of what?
Electrons, electrovalence.
Yes.
That the transfer of electrons. So electrovalent, they are exactly the same as ionic compounds. The opposite is covalent compound. Those covalent compounds, they share electron. So that means they take electron, and co means having the same thing, sharing the same thing. So covalent, they share their own valence electrons. Electrovalent means they transfer their own electrons. They transfer their own valence electron, and covalent means they share their own valence electron. When they say and co means when they share the same thing, when they have things in common. So they share their own electrons together. But this one, they transfer. So what we are concentrating on is just a compound that is formed covalently, which is what? Organic compound. Organic compounds are all covalent in nature. Please, let's see everyone. Is there anyone that doesn't understand it still? Please reply everyone. Please, please, please. Okay. It's just Kingsmith and thank God Mr. Ajayi replied. Mr. Shegun, yeah. Prodigy also replied earlier. Mr. B O G. Alright, that's very kind then. Okay, that's it about the first definition. When I say covalent, when I say equivalent. So organic compounds are covalent compounds that are formed by sharing of electrons between carbon and other elements, non-metals to be precise. Hydrogen, oxygen, chlorine, or nitrogen. They are the commonest elements that carbon react to form organic compounds. So after that, now I would like us to look at the characteristics. I asked Prodigy to help me look at the contents in the material, how they have been arranged. Okay, let me see. I don't know if you should just follow this next. So a very typical characteristic of compound, like organic compound now, is that they are all covalent in nature. They are covalent in nature. Please, we have the material. What will be the next thing? Please let me check it. I don't just want to be explaining what's not there. What will be the next thing exactly after that explanation of organic compound? Please let
Structural
me
formulas.
structural formulas. Okay. Stand. So talking about the formula, we all know that we have about three basic formulas for representing elements, compounds, molecules. So coming here, we have the empirical formula. We have the molecular formula, and we have the structural formula. So I'm going to make a relative comparison between three of them. Everyone, let's see. Empirical formula. It is just a formula that shows the relative. Okay, Mr. Ajayi, let's hear you, sir. I'm actually trying to explain now. Let's hear you first.
Thank you. This is our first chemistry class, right?
Right, yeah. Yes.
Under that covalent bond, they explain some things like dissociation energy, and then what is it called? Bond
Okay.
length, and under that covalent this thing. So I think we skip that. I don't. Maybe we should explain a couple of other.
Bacteria here. That's
That's
why
what
I
I'm just
said
talking about.
here. All right. Those are not
Yeah,
really. I'm very
it's
sure
under the.
but let's quickly pass through it easily. I'm very sure they only used it to explain some concepts under this covalent stuff. So we have what is called bond energy itself, and we have what is called bond dissociation energy, which might be the same and might be different. Normally, I want you to note one theory that bond dissociation energy for for molecules that are diatomic is exactly the same as the bond energy itself. Let me now explain what we mean by the bond energy and the bond dissociation energy. Look at this compound, the covalent compound CH4. Do you believe there is a bond that joins it together that makes it to be like this? You know, we have that bond in it. We all know that, right? So we have the bond that is in it. Exactly this bond here. So now that bond that is there has a particular energy that keeps it dragging itself towards them, right? So that energy that how do I put it? That brings the four atoms of hydrogen towards the central carbon. That energy is called the bond energy. I'm saying again that the energy that brings the four atoms of hydrogen, you know, we have CH4, towards the central carbon. You know, when they are being, compounds of carbon are stable. Yeah. So when they are combined, when they are combined, okay, bring it in. When the hydrogen combines with carbon now, we believe there is a force that keeps attracting this one to the carbon. Carbon will be at the middle. The four hydrogen will be distributed like this. First hydrogen, second hydrogen, third hydrogen, and the fourth hydrogen. So we believe that there is a force that keeps this hydrogen in it. You know, like a centripetal force that will make something to keep being in a circle. So that force here too makes this one to be on its size. That force is okay, like a gravitational force that the force of attraction between two things. So the force attracting this one to this one, force attracting this one to this one, keeping this one in shape, keeping this one to this one. The energy that is used for that work that force is actually doing, the energy is what we call the bond energy. So the bond energy is the energy that the bonds. This is a bond. This is another bond. This is another bond. This is another bond. So the energy that the bond possesses to hold the two elements towards each other. That is the bond energy. Now, bond dissociation energy is the energy that is required to break this bond here. If I want, you know, they are being combined with that bond energy. And I don't want to break it. I want to break them apart, like cracking them. The bond dissociation energy is the energy required to do that. That is the bond dissociation energy. The energy required to dissociate them, to crack them, that is to dismantle them, make them fall apart. That is the bond dissociation energy. And so we believe that the bond energy should be equal to the bond dissociation energy only by condition. Without that, it will not be equal. So and the condition is that it will be a diatomic element. When an element is diatomic, a molecule rather, diatomic molecule, hydrogen 2, you will believe this is diatomic. We call it atomicity. Why? Because hydrogen does not exist as ordinary H. Hydrogen exists as H2, so it is diatomic. Oxygen exists as O2. Oxygen gas is diatomic. Ozone exists as O3, so it is triatomic. So neon gas exists as one. This one is monoatomic. Chlorine gas exists as two. It is diatomic. You will never see chlorine like this. No, you never see chlorine like this anyway. It will react with another one that will form diatomic molecule. So that's what we mean. It's only for these ones that you see the bond dissociation energy equal to the bond energy itself. So, Mr. Ajayi, take it that way, and when you are going through it, I believe it will be better. You understand it better. Maybe when you go through the material for that. I really don't have the what is inside that material now. I don't have it with me. So please, do you get one or two things from there? All right, that's very good. Okay, we are talking about the empirical formula, the molecular formula, and the structural formula. The empirical formula is just the simplest formula in which a compound or a molecule will exist. The very simplest formula. Look at this. What I believe is that, what we all know rather, is that glucose has the formula of C6H12O6. Empirical formula doesn't do any work other than giving us the relative comparison, relative amount of the components of that compound. I have CH2O. Do you agree with me that these two formulas are the same? This is the empirical form. This is the original formula. Empirical formula shows the ratio. C is 6 here, right? H is 12 here, and O is 6 here. So now the 6 now, making it 1 here. Since H is 12 here, we believe H will be 2 here, and O is 6 here, O is 1. So CH2O is the same as C6H12O6. So that is the empirical formula. The molecular formula is exactly the formula that thing exists in, the form it uses to exist. While the structural formula now is what they use to represent it structurally. Now, like I have the compound like this. This is C, H, H. This formula shows the structure. It shows the bond. I have single bond here, triple bond here. This formula is a structural formula. It shows the structure of that thing. Now look at molecular formula. We are going to write the molecular formula out from the structural formula. This is a sign. I'm going to write the molecular formula out now. It is CH. That means I'm not showing the bond line again. I'm not showing the bond at all. So molecular formula does not show the bond. Now look at the molecular formula. Writing it. You know we have two C's. 2C, Abi. It will now be C2H2. So we call this one the condensed form. I don't want to enter that too much. I don't know if it's in the material. So CXHCH. So C2H2 is the molecular formula. Look at it very well. I'm giving another example. This is C. I haven't gotten this thing filled. H, C, H. Now look at what I have. Here now I have C, H, I have H, C, H2, Abi. Here I have C, H2. Here I have C, H3. Is that also? Is there anyone that's not getting what I'm doing here? Please just show a sticker fast. Please show a sticker if you do not get what I'm doing here right now. So I'll quickly go back before we go too far. Okay. So this is now HCH2. So condensing it now, it becomes CH3, CH2, CH3. Condensed form is now that carry all the C's together. C, that is C3. 3 C's. H together, 3H plus 2H, that's 5H, plus 3H, that is H, 8H. So this is C3H8. This is the condensed formula. This is the structural formula. The structural formula will always show the bond. That is what I want you to know. The structural formula will always show the bond, while the condensed form will only give you the overall representation without even showing it anyhow. This one is the molecular formula. This is the condensed form of formula for the molecular formula. So please, did we get that? Have I explained that now? Have I explained that? No reply, no reply. Yes, no, no reply at all from anyone. Kingsmith, please.
So that means for the second example, that means that the empirical formula will now be CH.
No,
For the second
because there is
example,
no
no,
ratio.
not that one. The second example.
Yes, thank you. Yeah. So empirical formula will be CH. It only shows the ratio they have to each other. 1:1 for C to H. That's very perfect. You are right. You are very right, Kingsmith.
Okay.
So please, is there anyone that has a question now or an observation that I also discovered that this, like Kingsmith mentioned now. Please, let's hear from you. I only saw Mr. Ajayi's reaction. I don't know if any other person understands. And you're not saying you're understanding or not. So how do I know? Well, I think as you're ignoring me, let me also ignore you. So please don't tell me you do not understand this point again. Because there is no yes, there is no no. That's very bad. So please, is Prodigy here? Please, what's the next thing there? Or who's going to check the material? One of you should please check the material. What's the next thing there? What's the next thing after this structural formula?
Orbital hybridization. Orbital hybridization.
Sir? Okay.
Orbital hybridization.
Okay. All right. Stand up. Orbital hybridization. Orbital hybridization is a normal concept that appears to be quite hard to understand. But I hope I'm able to explain it well that you understand it. Let's say what is hybridization. Hybridization is the formation of hybrids. We have ordinary orbital. That means the unhybridized orbital, unpaired orbital. And we have hybridized orbital too. Mr. Ajayi, do you have something to say first? Okay. I will say hybridization or orbital hybridization. It means the linkage or coming together of an orbital with unpaired electrons towards another orbital with unpaired electron in the ground state of an atom. So this is, we'll be taking carbon for our example now. Don't worry, you will understand me better now. This is carbon, 1s2, 2s1, 2px1, right? 2py1, and 2pz1. This is the electronic configuration of carbon. Don't question me today, so you can come to my DM later. You know what you are expecting me to write is 1s2, 2s2, 2p2, or 2px1, and 2p21. So wait, you can come to my DM for that. I won't be explaining it here. So hybridization for carbon means this S now is going to jump in its excited state. We know what excitation means. Excited state of atom. When atom jumps from its original energy level to another energy level. So the one now jumps now to fill another orbital. It jumps to this orbital, just an orbital. When it jumps to an orbital, this orbital becomes 2p orbital. So the orbital will be hybridized. So a new orbital is formed, right? Since it jumps into p. So we'll take it as a new orbital. That new orbital is called the hybrid orbital. It is called the hybrid orbital. That new orbital formed will be called the hybrid orbital because it only jumps to the first one, which is ordinary x, px. So this is called sp orbital. We know we have the s before. So this is ordinary sp orbital. When it jumps now, entering the first one and also the second one, it enters the second one. So it will be sp2. It's not sp raised to power 2. sp2 orbital hybridization. So this one is sp hybridization. This is sp2 hybridization. When it jumps until it gets to the third p, it becomes sp3 hybridization. So for sp3 hybridization now, carbon forms a single bond, C to H, to H, to H, to H. That is for alkanes. For the like C2H4. For sp3, it forms a triple bond for the alkynes, C2H2. The linkage or connection of an unpaired orbital, that means orbital hybridization, connection of an unpaired p orbital with the s orbital in the excited state of an atom. If it's a carbon, it will be excited state of the carbon atom. So when it now jumps from its original 2s, it's going to jump from this 2s. When it jumps from this 2s, yeah, it's not that I actually don't have the material that I'm checking out. So it will not be really easy for me to read out what you have there. So in summary, this is exactly what I was explaining to you then. So is there anyone that understands me here before I come again? Is there anyone that understands me here? Please show with reaction, even if you don't understand. I don't in a situation where it's not even response at all. What's your question, please? That's why I would like you to be reacting so fast. You know, once everyone finishes, someone finishes everything, finish. That's when you now say you don't understand. Instead of you to talk halfway, you're not getting it. See now, I'll now call again. King Smith, what do you have to say, please?
The thing was that for about 3 to 5 minutes we didn't hear you because of network.
Ah,
So that was why nobody reacted. We were not hearing you.
is it only, is
Your
it?
your screen just
Abi,
popped.
eh,
Yes.
huh, but, oh, okay, I'm coming again. Oh, no. So network cannot be properly. Wait, my network is fluctuating. Wait, I wanted to sub on the router. I made a mistake. The network is stable now. Okay, I think it's okay now. Right? Hmm? Okay, yeah. When we please again, I'm coming again. Now when we talk about hybridization, you're hearing me now, that's fine. So when we look at hybridization, when we talk about hybridization, it simply means the linkage or the connection between the p orbital and the s orbital. Now I'm calling it p orbital and s orbital because I'm talking about carbon here. So sp orbital. So I think it is limited to sp1, sp2, and sp3. Ordinary sp, sp2, sp3. So, and I'm saying again that it is the connection between orbitals move together. Two, okay, okay, I should see a better way now. Hybridization, orbital hybridization is the coming together of two unpaired orbitals to form a new orbital. The new orbital is known as the hybrid orbital in the excited state of an atom. In the excited state of an atom. So this is S. Look at it very well. The S orbital is like this, right? So the orbitals they will have the same quantum number, principal quantum number. That's a very important thing again. So okay, if you are going to write it down, I've got a better way. I've gotten a better way to explain it now, to define it. So hybridization is the coming together of two unpaired orbitals with the same principal quantum number, with the same principal quantum number to form a new orbital, which is known as the hybrid orbital. It is the coming together of two unpaired orbitals. Look at the S here, it is unpaired because it is just one. It is 2s1, it's not 2s2. So two unpaired orbitals, that means S and P now, to form a new orbital. So because of the both of them have the same principal quantum number, so to form a new orbital, and the new orbital formed is known as the hybrid orbital. That's what I want you to know. The new orbital formed is known. Oh, thank God. The new orbital formed. I hope someone else is getting it too. The new orbital formed now is known as the hybrid orbital. So now the hybrid orbital formed, it's always in the excited state of the atom. When electron jumps from one energy level to another energy level. When it is to this energy level, we call it S and this Py. It is sp2. If it is S, it will be sp3. That's what we are saying. So sp hybridization just means the linkage of the s orbital and the p orbital. That means the first p orbital, that is px orbital, to form a new hybrid orbital. Sp hybridization is the linkage between the s orbital, unpaired s orbital, and unpaired px orbital to form the hybrid orbital in the excited state of the carbon atom. If it is sp2, it will be the unpaired s orbital and the unpaired py orbital to form the hybrid orbital. It will be sp2. Now, let's call this one p1, p2, and p3. And if it is p3, it will be between the s orbital and the p3 orbital. They are both unpaired, and unpaired means they are just filled singly, and we'll have this. So please, is there anyone that has gotten it again? I think I have just two people that said they got it right. Kingsmith and Mr. Shegun. Okay, Mr. Ajayi, that's very good, sir. So I would like you to just go through your material. You get one or two things small. Please, I believe there is someone else here now. It's just those of you that have the first page that I'm saying. Mrs. Aloba, Adenike, Aminat, K, Naomi, none of you is replying. So I just hope you are getting it. So, since you are not replying, so I'll just ignore you guys. Kingsmith, please, let's go.
Sorry, I'm sorry, Ali. I just joined. I'm not doing the course.
Sorry, because you want to come and see my face. I think go.
Subhanallah.
Please stop my class, so. Please stop my class.
Okay.
Kingsmith, now is it not because of me that she adding herself?
It's not because of you. I just.
Kingsmith.
Now because of him, Jerry. So what I want to ask is, I noticed that as the X being excited is jumping to the P, we are now having
Yeah.
XP raised to power 2, SP raised to power
Don't
2.
call it raised to power 2. It's SP2. You understood it. You definitely understood it. That's it. But it's not SP raised to power 2. SP2.
SP2. So.
Wait, my brother is calling. Wait, I'm not hearing you.
Okay.
All right, yeah.
Okay, what I want to understand is the 2 and the 3, is it showing that X jump was excited to jump inside P? Abi I no get.
The 2 and the 3 is showing that the electron is the orbital, s orbital is actually pairing, it is mixing with the py or the pz. If it is, let's say this is for one ordinary sp1, that's ordinary sp.
Okay.
So sp1 will be for p2, spz will be for p3. If it is for 2px here, so it will be ordinary sp. If it's for this thing and 2py, it will be sp2. Within, see, this is first, second, and third. So if it is for 2pz, it will be sp3, the third one. That
Okay.
is the meaning.
Okay. Okay. Okay.
Right. Please, any question from anyone? Okay, I think I've explained hybridization by, okay. All right, good, my bro. Good, good, good. All right, please, what will be the next thing then? We're going to go be the next thing after hybridization.
Functional
This
group.
supposed
Functional group. Functional group.
functional group. Oh, okay, functional group. Functional
Yeah.
group it's something close to homologous series. I believe we've heard of that before.
Yeah.
Oh, many of us are just like, and so one person tell me say don't reach 14 years when you leave secondary school. So even if you heard of it, automatically you don't forget that. You don't forget it. So so let's just be relating small small, don't worry. Let's be relating small small. So what did we say? Functional group. When we talk about the functional group now, we are talking about the CH group. The CH group. Functional group is the CH group. What do we mean by that? We have different functional groups. See me. You see that an an organic compound ends with COOH. You see somewhere that an organic compound ends with OH. You see somewhere that an organic compound ends with OR or OOR. So the group means exactly the general form in which different homologous series exist. So functional group means this is what I'm going to use to understand, to know this homologous family. You know homologous series like alkane, it contains alkane, it contains methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, dodecane, undecane, duodecane, and the likes. So that one now, what is going to let us know is its way, the way it increases. That's ordinary CH. CH. You can see that that one we have what we will use to know that this is not this one, this is not this one. But the similarity they possess that we can use to say that this one is inside this family. This is inside this family. That is what we call the functional group. That's what we call the functional group. The similarity each homologous series possess. This is the homologous series. So when they are the same homologous series, that means they are family. So what we use to represent them, what we use to recognize their family is their functional group. So please take it that way. When they are in the same homologous series, they have, okay, I think I told you. Okay, sorry, it was a call. I said when they have the same, when they are in the same homologous series, means they are the same family. So that thing that we use to recognize their family is what we know as functional group. All right. I think that's covered. What will be the next thing, please? All right. Thank you, Kingsmith. What will be the next thing? Next thing, please. Sir?
nomenclature of organic compounds.
Nomenclature. Nomenclature. We'll just start nomenclature. The five nomenclature there. Thank God, chemistry courses not too much. When we talk about nomenclature, I'll just be pointing out a few things tonight, or maybe the next class we'll do another thing. And we might probably finish everything today. When we talk about the nomenclature, we have what we call the root of the molecule or the compound. We have what we call the prefix. We have what we call the suffix. We have what we call the suffix too. So, and numbering is also very important. This is a compound. C, 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 C. H, 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 H. Before we know nomenclature, it is very important to know this thing. They didn't arrange that material. Who can tell me the name of this molecule, this organic compound here? I'm giving is it the structural formula I'm giving now or the molecular formula? Who can answer that first question now? That question first. Is this the structural or molecular formula? Six mates.
Okay, is the
Six
structural
mates. That's very perfect. So now, yes, sir. Who's going to tell us what the name of this compound is? The name of the compound on the compound. Pentane. That's very. Pentane means C5H8. C5H12. So you are very right, sir. You are very right. That's good. I've seen someone that I'm sure he knows it. I believe Prodigy should know that very well, Mr. Akionla. Kingsmith knows it well too. So I don't know. Now, definitely, we know what pentane is. I'm trying to see if we all know what those things are, because I can never explain nomenclature without you recognizing all these things. So let me quickly prove it first. Else there will be problems at the end of the day. You expect them to bring nomenclature so fast. It's very simple, though. When you get there, there's something you need to understand. These are the homologous series. We have them so many. We have the alkane family. We have the alkene family. We have the alkyne family. We have the esters. We have the carboxylic. We have the alcohols. We call them a name. We have the alcohols. Those are the ethanols, methanols, propanol, butanol, or stuff like that. So we have the alkyl group with salt. We have the esters too. We call them the esters. They are the salts. They are just like salt formed by esterification. That's organic neutralization. So the alkane now, there is a general formula for it. The alkanes are saturated and they are single bonded. So, but before I start writing it out, please note this thing very well. Alkanes are saturated, alkenes are non-saturated, and alkynes are also non-saturated. Please, Kingsmith, are you saying it well like this? The way he slanted it, my brother is doing it upside down. Are you saying this or well? But you should take it back. Kingsmith.
No, but maybe if you finish writing, he will take you back.
Okay. This is single bonded. Alkenes are double bonded. Alkynes are triple bonded. Triple bonded compounds. They have many differences between them. The reaction with AgNO3, the reaction with boiling water, the reaction with several things, their catalytic ability, how they burn in water, how they burn in air, stuff like that. So now, I'm taking just these two because of the structure. The first family of alkane is methane. We call it methane. CH4. We call it methane with CH4. How do you know that CH4? There is a general formula for alkanes. CnH2n plus 1. Please know the formula. Very simple. plus 2 rather. Alkane has the formula for CnH2n, while alkyne has the formula of CnH2n minus 2. Is there someone moving with us with this? Please just show with the reaction. We get to see everything again. Thank you. Yeah, I have 2 people moving with me here. Yeah, more than 2 there. All right. That's good then. Okay. CnH2n plus 2 means the first family of alkane will be number 1, abi? So n will be equal to 1. So C1H2 times 1 plus 2. That's C1H2 plus 2. That's C1H4. 1 is ordinary C2 like that. CH4. This is the first member of alkane family. The first member of alkane family. So it is known as methane. 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 That's the first member of alkane family. Methane. CH4. Methane. The marker is acting well already. I haven't gotten the. I went to some other part today. So I had to get power bank and some other stuff for myself. And things I wanted to get before. So I just did everything together. So they can lie running came back very late. So it's so filling branch and the bookshop again. Okay, even though this is a new marker, the new marker is cannot. So the next one is using the formula again, CnH2n plus 2. The next one is the second member, right? That will be C2. So C2H2 times 2 plus 2. So that's C2H4 plus 2. That's C2H6. So please, I want someone to compute with this formula. I know you know them before, but use this formula now to compute them from number 1 of this group to number 10th member of this group. So please, everyone, do that. From the first member of the group to the 10th member. 10th is too far. To the 5th member of the group, please. So what will be the... let me do it this way. That's too... just wasting my time. That will be wasting our time. So what will be the next one after methane? After ethane. After methane, it is ethane. Ethane is the second member on the second bond family. So ethane. After ethane, it is what? What is its name? What is it?
C3H8.
C3H8. Perfect. So, and it is known as what? C3H8 is known as what?
Propane.
Perfect. So after propane, Mr. Ajayi, can you tell us the next one? After propane, its formula, its name. The next
C4H.
Butane.
C for H what?
C4H10.
Perfect. And you called it butane. That's very right. So, and the next one now, the words after butane.
Pentane.
We have pentane. That's C2H12. C5H12.
C5H12. That's very perfect. Don't let me disturb myself on that one again. We've understood it. So as for the alkene now, CnH2n is the formula. This one, I want you to note one very important thing, that alkane doesn't have first bond. Their first bond is dead. Their own first bond is dead. So so now is the second bond no longer take a position of first bond. Understand? So please remember that fact. The first bond are kin otiku at your kind. First bond otiku. So it's the second bond you're starting from. You will never see C1H2 times 1 in alkane. So that you'll be having CH2. No, in alkane, there's nothing like this. You know, if it is the first bond, I must obey the thing C1H2 times 1. That's C1H2. So there's nothing like this for alkanes. Most of the family one, first bond one, so it's going to be C. So their family starts from second bond. Then C2H2 times 2. That is C2 H4. So you don't need to say methane. There is nothing like that. The one you need to say now is ethene. That's the second bond. So we don't take position first bond and a choice. Please, do you understand it? That ethene is the one representing their family now. So please, who will give us the next member of this group after ethene? What is its name and what is
That's
its
propane.
formula? Propene. Propane.
That's
ENE. Don't forget. ENE now is the function.
C3H.
ENE is the functional group. So propene. What do you call it? So we mentioned functional group earlier. So now look at the functional group now. The functional group of alkene is ENE. That thing that we use to be representing its family. You understand? Alkene, it will be ethene, propene, butane, pentene, ethene, octane, heptene, like that. You understand? That's exactly what we mean by functional group. Please mute the mic, sir, Mr. Ajani. So C3H6, I think you've said that already. C3H6, that is propane. So what will be the next family of this group? Anyone here? What will be the next family after propane?
Butane. C4H8.
Putin. Putin sounds like Putin, president of Russia. Putin. So Putin is what? What's the formula for that? Uncle?
C4H8.
Perfect. So that's just CnH2n. Now going to the last one. I told you, family are related, but the perfect one. The same thing is happening to them too. So there's nothing like methane. So the functional group is ine. Ine as in K when you are reading ine. So ine. So you do methane, germ or something like that. So CnH2n, no first bond. Second bond.
I mean, we know that one very well.
I mean, I look well now. C2 H2 times 2 minus 2. I mean, you haven't left. Hey, yeah, because of me. Sure, don't die because of love, bro. No problem. What you say is because of
Today
me.
is Valentine now, so after class.
Andre.
Sorry.
No polyvarsot.
H4 minus 2. So C2H2 is the first member with the name of ethine. Ethine, not me. It is a, no me in their family. No firstborn. So please, what will be the next member? CnH2n minus 2 is the general formula. CnH2n minus 2. What will be the next member in this family? The next member, please.
C3H3.
C3H3. That year go the H3. Next member, please, after a time.
I'll be C3H4, sorry.
Perfect, bro. C3H4. That is kilo
Protein. Protein, sorry.
Propine.
Propine. Yeah. Propine, yeah.
So that's very nice, bro. The next one, please, from anyone. You just need to know the general formula. Once you don't even need to cram it. Once you have seen it very well, it will become your blood. Another person, please, for the next one. C4H6. That's also very right. C4H6. With the name of what?
Butane.
Okay, what will be the next one? Mr. Shegun, are you here?
Yes, I'm here.
All right, sir.
Pentane. H8.
Pentane. H what?
8.
H. Okay, that's very right too.
Pentane.
And the next one is what? What is it?
Hexane.
Hexane.
H10.
With C6 H what?
H10.
Perfect. So and like that, they keep going down. So this alkyne is an homologous series. The functional group with the functional group of just because of one thing telling me that our chemistry course is not much. I would really like us to do the naming of nomenclature, naming of the compound. But the marker is tomorrow. I'll just get it settled. Stand. So it's already acting well. It's already acting well. I bought one yesterday and it's already acting well. Used it in the schools I went to today. So I gave them some documents. That's right. Okay, please let's take it like this at the moment. I believe in one or two ways. Many of us have learned one or two things. So may God keep replenishing our brains. All right. Thank you. Thank you very much for listening. Thank you for being good. Thank you for coming down. Thank you for understanding. Thank you for asking questions when you have problems. Thank you for thank you for understanding. Thank you for having a